This is the prep packet video for Unit 3, Chapter 8.2, and we're going to be working on objective number 4. So in this case, we are going to be working with rational expressions, aka fractions, with different denominators. So again, I think I talked about these as being friends or strangers. So let's take a look at a couple of things before we get started that I want you to keep in mind. So number one, when you're presented with fractions that have different denominators, so here's one. Sorry, this is kind of, the bad writing is back. So here I have 3/7 minus 1/14. And what I need to do first is factor. And I'm going to factor my denominators. Okay. So 3/7, those are both prime, but 1/14, 14 is the same as 2 times 7. Okay. So the greatest common factor between 7 and 14 is 14, and I'm going to write it like this. And what I want you to think about right now is the fact that we're going to now we're going to find, helps if that has an I in it, find what's missing. So in this case, 7, we have a 7 there. So what's missing for this fraction is 2. So I'm going to multiply it by 2/2, because what I do to the bottom, I have to do to the top. And I will end up with 6/14. And then I'll subtract 1/14. And again, leave those denominators alone. They're going to stay 14. But 6 minus 1 is 5. So we'll have 5/14. So we factored the denominator, we found the missing factor, and we fixed it. That's the fix. So factor, find, and fix. Go ahead and copy these, and I'll meet you on the next slide. So here we have two rational expressions that we need to combine. And the first thing we want to do is factor. So 5 is prime, but 10 is not. So if I factor 10, I have 10 equals 2 times 5. So my greatest common factor is 2 times 5, or my greatest common denominator. So I factored number 1. Now I have to find the one that's missing. 5 goes into this, there's the 5, and the 2 is left over. So that's the find. And now I have to fix. So I'm going to say 2 times q minus 3 plus, didn't have to do anything to this piece, so q plus 6. And all of that is over 2 times 5. Okay, now I just need to keep going. I'm going to distribute. So 2q, 2 times 3 is negative, so that'll be negative 6, plus q plus 6. My 6's cancel out. I'll combine 2q and 1q and have 3q. I can go ahead and put this back together. So my answer is 3q/10. Let's go over here now. This one's a little more involved, but not too much. So there's nothing I can do vertically. So let's take a look at factoring the denominators here. So for this one, that's my first f, I'm going to factor k squared minus 16. Woohoo, difference of squares. So I have k plus 4 times k minus 4. And conveniently, that k4 will work here. So there's my greatest common denominator. And now I have to find out. I have to find the missing one. So here's k plus 4, here's k plus 4. So this is the factor that's missing up here that I'm going to have to add in or multiply by. So there's k minus 4 over k minus 4. And if I do that, then all of a sudden I have two denominators that are the same. So now this is what it's going to look like after I fix it. I'll have 3k minus 20 plus k times k minus 4. And all of that is over k plus 4 times k minus 4. Now let's do some work up here. Let's see, I have 3k minus 20 plus k squared minus 4k. And let's combine them. K squared will be first. 3k minus 4k will be minus k. And that leaves me with the constant of negative 20. And that works out to, I can factor that as k minus 5, k plus 4. Okay? And I'm going to go back and I'm going to use my original denominator that I liked so well, that I worked so hard to get. K minus 4 times k plus 4. And now I get to cancel out because there's 1 right there. And that leaves me with my answer, which is k minus 5 over k minus 4. So go ahead and stop and copy, and I'll meet you on the next slide. Here's two more problems. This one's a little more involved. We still have m's in the denominator, but finding a common factor might be a little more difficult. So what I like to do, I'm going to do my first f. I'm going to use a pen. Factor. Okay. So here I have 3 times 3 times m. And on this side I have 3 times 4. I'm going to be a little tricky. Times m to the 6th. And you'll see why I'm doing that in a minute. So if I'm looking for the greatest common multiple, that's it. That's the word I've been looking for. The least common multiple. Let me write that down. Least common multiple. That's the word I wanted. Anyway, I'm going to do this. Here's a 3. So there's a 3 in common. There's another 3 in there. And then an m. So that goes away. And then over here I have a 4, and I have m to the 6th. So that's the least common multiple, which would be 9. 3 times 3 is 9, right? 9 times 4 is 36. M times m to the 6th would be m to the 7th. That's what it looks like, but I'm still going to play with this one because it's going to make my life a little easier. Okay, so I'm going to change colors again because I can. So 3, there's a 3 there, there's a 3 there, and there's an m. So what this one is missing is this. So I'm going to have 8 times 4m to the 6th. No, I don't want that color. I want another color. Let's do orange. Ooh. This one, 3 to the 4th, 3 times 4 times m to the 6th. Okay, I've got that. I've got that. I've got that. I've got that. Oh wait, I didn't have to do anything because 12m to the 7th will, the only thing I need to do is that. Let me just look at that again. I've got the 3, right? I've got the 4, I've got the m to the 6th, I've got the m. So the only thing I have to bump this up by is 3. So 3 times 11. And all of that is over 36m to the 7th. So let's do a little work. 8 times 4m, so that would be 32m to the 6th minus 3 times 11 is 33, all over 36m to the 7th. So we would love to factor that. I see all these 3's floating around, but this is not a multiple of 3. It's 8 times 4. This is 3 times 11. So you get to leave that just the way it is. This one's done. So I factored, I found what was missing, and then I fixed it, the 3 F's.